we are live.
Okay, there's a problem, man.
Oh, which problem?
Your voice is too, how can I say, the opposite of loud.
Oh,
Too
what?
quiet. It's too quiet, and the bot is actually at this almost at the same level as you are.
What the fuck,
And I'm
man?
too, yeah, and I'm too loud in comparison to both of you.
That's so weird. I just seen this stuff.
You,
Configurations here is just the same.
yeah, you need to increase your, I don't know.
Oh, wait. Oh, fuck, man.
Holy Jesus.
Oh, is it better now?
Yeah. Now keep talking.
Okay, I was using the webcam microphone, man. Ah, that shit always happens. Yeah, now I'm with the correct one, I guess.
Now the bot's too quiet.
Oh man, wait.
We need to have a better way to do this, man. Holy Jesus.
Okay, let's try it now to see if the relation between my voice volume and the bot volume it's fine. It's okay.
That's fine. Now it's fine.
What about your voice? Could you?
Let me just skip because this part of the song is the guy's already talking a lot. I think I'm also fine.
Okay.
Oh man, but now I want to check. Life is hard. Okay, so now I'm talking just to check the audio. Talk also, nothing.
Okay. I'm also talking, just for the purpose of testing.
Okay. Decrease 5% of the bot and let's go.
Okay. Can I do it from? Oh, I can do it from here. Okay.
Okay. Okay, I think we're fine now. Okay, so what are we gonna be doing?
Oh, you need to share a screen just to remember.
No. Go live. Okay. Okay, so what we're doing, we have a file called Dr.drn, .drn, sorry,
Okay.
and this is the compressed file. So, for instance, this is smaller than the full-blown version, like of the text. This is just like really smaller than this, because if you count, you have I don't know how many things we have in here. We have 12 time. Okay, so I have 96 bytes, and the compressed version is only 10 bytes.
Mm.
So what you want to do is to read this file and get the original one with no losses.
Okay.
And what we did previously, we basically created this file, and the remaining piece from last session was basically these 3 lines. So what is this doing? Okay, no, I lied. Is this all these lines were missing? So what we are doing here, we are basically printing into a file with the new file name, and we are writing a sequence of vector of U8s. So that's basically what you're doing. And someone is calling me. What? Just one sec. Are you there?
Yes.
Okay, so what we want to do today to finish this is to pick this 10 byte file, read it backwards, and then get the original content.
Wait, read it backwards?
Yeah, so okay, I said I did wrong. It's not exactly backwards, right? It's a little bit different than that. You're gonna read it normally, but you're gonna do, instead of, we're gonna decode the information that we encoded inside it.
Oh, okay.
Okay, so the first thing I need to do is to create a vector of u weights, because this is the unit that you're going to be using to read. So let's pick, I don't know, a buffer. This is a
DRN file.
mutable buffer. Let's give it a type, which is going to be a vector of u8. Okay, man, this bot is too loud for me. Wait. Yeah, this bot is too loud. Okay, now it's okay. Talk a little bit, Nata.
Okay, I'm talking.
Yeah, no, I can hear you fine. And now the bot is okay. Okay, so we have a vector of u8, and where we're gonna be storing the information.
Is that return type right? You're returning your...
Yeah, this is the... Okay, this is not. This is actually a vector of u8s. Because this is gonna be the file content, right? The file, the final, like this. This should be a u8 of this. So, yeah. So let's do a open. Oh, we are opening the file and then trying to find it, and then.
Oh, we have better handling now.
Yeah. In the future, we also gonna do it better. So let's read this. But there's a problem, right? Because this is going to return some sort of result, and we don't want that. Is this right? Yeah, this is returning a result. We don't care about the result. But that kind of doesn't matter, I think, because we just care about the buffer. And I think this is a reference. Is that correct? No.
But are you sure? Like, maybe we don't need the content of the result, but don't we need to know if it was successful or not?
We kinda do. We kinda do need to know if it's successful or not.
So you can.
But I think this is already doing that, no? It does.
This is for opening, right?
Yeah, this is for opening. If you don't find a file,
there you are reading. I'm not sure specifically which part can fail when reading. But, well, if it returns a result, you can just read the error and ignore the content of the result.
Okay, so how do we do that?
Well, as you are doing there with expect, you could just use the same, I think. I'm not sure what would be the error message, because I don't know what fails when reading the file. You could just reading the file or something, but...
Error reading the file. Okay, so there's also a problem. Because the buffer... This is not...
mutable, right?
This. Okay, so now the buffer... okay, so the buffer is the content of the file. Okay, now we have a problem. Now we do have a problem. Because we are pushing it this... which is 8 bits. So we need, so the first, yeah, so we're gonna have to make a hash map here. So let's make a mutable symbol symbol hash, which is basically gonna be a hash map of a string to a string. And let's do hash new, because now we're gonna have to reverse engineering this for, basically, because we're gonna have, this is 1 byte, this is then 1 byte, and then we need to read the bits, and that's the part that's gonna suck. So 4 byte in buffer, so but this needs to be ether. We need to do some sort of symbol. Okay. Oh man, we cannot do a for like this, which sucks.
Oh wait, what? Why?
Because we need to, like, we need to do 3 steps like
Mm.
we need to consume 3 bytes in one go. So
Uh,
I think we need to do ranges in this case.
but can you set the step for the range? Oh wait.
I think we do. Set
Mm.
step for range rust. A custom step. You see?
Oh, that's nice. It's like a method of a range.
But
That
here we're gonna start with 0, and this is gonna be buffer dot
man,
land.
that looks like a nice API. Well, at least a consistent one, but
And there's another problem though.
mm.
We want to do each step 3 going through the multiples of 3,
Yeah,
but
but not necessarily they are
not
divisible by 3, right? Or are
no,
they?
they are not necessarily divisible by 3, but the thing that matters, no, actually they will be. Yeah, I think they will be. I think we're missing something now. Wait a second.
Mm.
I'm kind of starting to think that we need to add to the header how many bytes of dictionary we have. Uh, Let me go to my original implementation. You see what I'm talking about?
Not really.
Okay, so do you remember that we have a dictionary, right? That we are saving to the beginning of the header?
Yes.
So we need to know how many bytes that this dictionary occupies, right? Because then we're not gonna know. Okay, this is the end of the dictionary.
Oh, you want to ignore that part, right?
Yeah, I don't know what I did.
Well, ignore as a content, but you wanted to get this in the data structure, right?
Yeah, I think we need to write that, man. Overhead, saving the Huffman tree into write into the output file byte by byte. Yeah, but I'm not doing it here, which is kind of curious. How are we gonna know when the dictionary ends without that? Is that a way to know that?
Can you remember where you were like
Yes, I
uh
can.
where you were like constructing the header for?
Yeah, so I was in the code. Okay, so we are constructing here basically. So we are iterating
No, but
through
that's a
the.
header cell, right? Don't we have information regarding all the header? Like, uh,
Oh, but this is the beginning of writing the header. The header starts by picking a symbol, how many bits it will occupy, the bit representation is, and then the bits themselves, right? And then yeah, and then we are picking and then we are writing how many bits of padding we're gonna add. So we are informing. Yeah, man, I think we don't have a choice. We need to tell how many bits, how many bytes is this loop. Yeah, I think this makes sense. And so let me draw a little bit, so that it's gonna be easier to understand what I'm talking about.
okay.
So I don't know, draw. Okay, so what we have a header, right? We have a header. Uh, okay, this is fine. We have a header which is composed of a dictionary plus bits of padding, right? And then we have the payload, which is actually the translated content. So if we start thinking about the dictionary, it's composed by a list of triplets, right? So it's a list of triplets, when the first member of the triplet is basically the symbol, so that would be the letter A, B, and C, and then how many bits the bit representation is, and then the bits themselves, right? And we have a list of those. And the padding is a byte. Padding is a byte. That tells the decoder how many bits at the end of the file should be ignored. because this is to account for the multiple of 8 thing to have a, because the atomic unit that we deal with is bytes, are bytes. And then we have the content itself plus the bits of padding, right? So this is
So we need
useless
what, like
bits.
1 byte at the beginning of the header to say
Yeah,
like the
I
size
think
of
we
the
need,
dictionary?
yeah, how many by dictionary bytes? And this is basically going to be a byte. I think we don't, because we need to do a for from 0 to this. Do you agree? Like, how are we gonna know that this list ended?
It's not quite 0, right? But we'll use this to go to the dictionary, right? To the
Yeah,
dictionary
exactly.
part.
We're gonna do from the beginning to this guy. The for will go from 0 or whatever the first unit is to this guy. How many dictionary bytes?
Okay. Okay. Dictionary
Um,
size, dictionary itself, the padding. Yeah.
yeah, I don't think there's a way to get around this. We need to put this in the beginning, which sucks, but that's fine, I guess.
1 byte, right?
How many bytes? And this needs to be mutable, and this will start from 0. And we're gonna do how many is this a thing? Can we do this?
I hope so.
Okay, nice. Uh oh, there's a problem. There is a problem, my dude.
Mm, okay.
Wait.
Oh, wait. Hey, man, we had to reset. Oh, wait, Lemus.
This need
Wait,
cannot be here.
that's not C. Yeah, that's not C. You have header cells already, right?
Yeah, but we need to count how many header cells we have.
No. You have a vac, man. Just get the size of it.
Okay, that's a better solution. So let's eliminate this, and then we're gonna do bits push as string, and it's basically gonna be, I hope, like this. It's gonna be something like this. But in cell dot symbol, this will be header cells dot len, like this. This should work fine, I guess. And then if we just comment this out, hello.
What the fuck was this? Oh, okay.
And if you go here and do Huffman cargo run, this should produce a thing with 11 bytes as far as I can tell. Okay. So okay, so I cannot get this information from
What
here.
about command line?
Properties? Yeah, 11 bytes.
Nice.
Okay, so I think it worked. So now we can just go back to this loop.
Ignore a
Which
byte.
means that the first guy is how many bytes? So this will be buffer 0. But I think I need to borrow this because this is still part of the whatever the heck. Can we pop something from a vector?
Not sure.
Okay, so there is a pop here.
Oh, nice.
But this is an optional one, which sucks. Can we unwrap it? Yeah.
Oh my.
Okay, so let's try to do a simple print. What is the thing? It's something along these lines.
Yeah, that's the debug one.
How many? Okay, so this should work fine. And then if you go here, let's do IO read this, and this will be test drn, and this should work just fine. So let's go here and cargo run. Oh no, I need to change the type.
Yeah.
Yeah, I need to remove this for now. I need to pay attention to the chat, right? I forgot.
Oh yeah. Oh wait, you are showing like whatever you are having on the screen. You are showing that.
No, it's fine. That was Dr.Nekoma
Okay.
thing. Okay. Okay, so I'm paying attention to the chat now. Okay, so 21. Is that what we want? I don't know. Which means that we need to print this. I kind of think that's wrong though, but that's just a feeling. Okay, so if we request to print this guy.
Oh wait. Is it because?
Okay, so this is definitely wrong.
Yeah.
Can we agree?
Yeah, this is supposed to be the number of.
Three.
No, but is the number of like symbols, right?
It's the number of cells. So this should be 3.
Okay.
Wait, and it's 21, which is really wrong. Okay, so now I want to kind of guess. Can we print this? That would be really nice. 3. Huh. Can we print this? This is also 3. Huh. Yeah, so I kind of don't know.
Can you go on where we are getting the 21?
Yeah, here.
Okay, so we are printing how many dicks? So
Oh, I'm picking
pop.
the pop. So I think I need to do. Maybe pop is the last one, not the first one. Which kind of. I don't know if it makes sense, but anyway. I need to own this. Okay, so what's the type? Okay, you wait. Okay, 3.
Okay,
Nice.
pop was.
Yeah, pop is the last one, not the other, which is fine. Makes sense. Okay, with this out of the way, now we can make our loop work. Because now we do from 0 to how many? How many? And this is always advanced by 3.
Isn't how many plus 1 or something?
Maybe.
Okay. No, that's right already. We are not doing the inclusive one.
Yeah, okay, makes sense. Okay, so, man, but there's a thing. There's a thing. I think we need to map this buffer. You know why?
Why?
Because the bits are not multiple by 8. They're not like 8 composed by 8 and 8. They can be 2 or they can be 3. So I think it's worth to transform this UH to a string. I think it's a good idea. So let's do this map, and we're gonna have something like a byte in here, and we need to transform this with format to 8 bits, like this. We need to do something along these lines. And then we need to flatten as well. And this will be actually like a stream of bits. And this needs to be mutable. I don't think so. And then we're gonna do format, whatever is this, so byte. And then we're gonna also do flatten. I don't know if that's gonna work though. I would be really surprised if this works. Oh no! This is a type flatten. I don't want to do that. We already did this previously. How did we did that?
I don't remember where.
I think we nuked because we saw that we were being dumb, and then we removed the flatten. I think it's collect, maybe. Something in my mind is talking about collect. Collect. Is that what we want? I have absolutely no clue.
What's the type of string of bits?
That's a good question. It's not saying.
Can you hover?
Hover. Unknown.
Oh, that doesn't sound good.
Okay, so let's try to search about like flatten a vector of strings. Rust.
Oh wait, again. I don't think that's flattened. Yeah, that's definitely not flattened.
There's something called connect.
Mm.
Oh no, but this is and this is the old way to do it. Oh, this is join.
Oh, makes sense.
I don't know if that makes sense, but join, and we want nothing. Okay, it's a string.
Yep.
Okay, so let's try stream of bits, which is basically what this is. So let's do cargo run here. Yay! Returns a reference to data owned by the current function. I don't know what you mean, partner.
Not return reference to temporary value.
Cannot return reference to temporary value. What an interesting error.
We are mapping the byte. What is the result of the format?
It's I think it's a string, man.
But which one?
Yeah, it creates a string using interpolation.
Oh, so remove the as string.
Let's try that. But that would be a really bad error message if that's the case.
Well,
yeah, I need it.
Well, for us that don't know the language, maybe it is, but
no, that should be a type error. Not returns a reference to data owned by the current function. This is just like this is not a string. This is a different type of string. That should be the error message. And this is correct, I think, because the first 3 ones they.
yeah,
Wait.
but I don't know what you mean by a type error though, because it's a map, so it's like A to B. Doesn't need to.
Oh, you're right. We didn't put the signature. Now it should be a type error.
Oh.
So let's try. Let's try. Oh, there's a problem.
Which one?
Before doing this map, we need to get the how many. Okay. Okay. And then we need to pop it. How can we pop?
Can you see if we have a method for
Remove first element of vector rust. Move the first element. Idiomatic way. How nice. Okay, so apparently this is not a thing, apparently. Oh no, people are making functions.
Well, I would have guessed that you would have to move a bunch of stuff, right?
Just want to remove the... Oh! No, we can just start from 8, this loop. Okay, it's fine.
Oh.
Okay, it's fine. So we get how many here. We don't have this anymore. This is the hash that we're going to fulfill doing this for. And instead of starting from 0, we're going to start with 8. Right? And this... How many bytes? I think you need to multiply this by 8 as well.
Parentheses.
Because now we are kind of iterating through bits now, not... And this step is also going to change, I think. I think it is smarter to use a while in this case.
Wait. What is the... No, wait. Why do you need that? Because you need the iterator?
No, because we're going to be doing... the way that you're going to iterate through the loop changes through time.
Hmm?
It's not always 3. It's not always 3, you know? This is a dynamic rule.
No, I mean,
Sometimes it's going to be...
I
Yeah.
think, and maybe it's fair to assume that if you have steps of 3, and the thing is not divisible by 3, you either will have an error, or on the last one, you will just get less than 3.
No, but that's the thing. It's not going to be 3, man. Just trust me for now.
Okay.
You're going to understand pretty shortly. So, while index is smaller than the stream of bits.len, while this, you're going to do a few things. So the first thing that we need to do is the index is actually going to start from 8, not from 0, because we are already like... and this is actually also actually not correct. This is how many times 8. Okay, now it's correct. We're gonna jump through this guy, how many symbols. This is why we're starting with 8. And then we're gonna do the loop until we finally we surpass the dictionary of symbols. Each symbol is composed out of 3 things. The symbol itself, so let's make a let symbol here. And this will be from the stream, starting in the index, going all the way to index plus 8. So this is the 8 bits. This is 8 bits. This should be a string. This should be a string. And then after that, we have another 8 bits, which is going to be plus 8.
Oh my god.
No, we're going to change this shortly. This is just for getting our heads wrapped. And this is going to be the size. Right. And then there's the trick. This is where the dynamic behavior starts, because then we're going to have a bit representation, which is also a string. Right. And we actually need to convert this to back to a U8, because this is a byte now. And this also needs to be converted back to a number. So I actually want this to be, I don't know. Yeah, U8 is fine, I guess. And then here's the trick, because this is still be a string, but this will be the stream of bits going from index plus 16, index plus 16 plus size. And because the size varies from traversing the symbols, we don't have a rule to do the step, a fixed one. And then you just need to do index plus equal 16 plus size. I guess.
That looks very weird, but well, we have to.
But I think there's a problem, man. I do believe there's a problem. I think we need 2 indexes now. Let me try to explain why. Because we also and this starts by 0. Yeah. So we need to do index 2. I will explain this again, just to us to be on the same page. And then this, and then just this. Okay, so one index is to iterate through the stream of bits. Okay, and the another index is to iterate through the triplets. These triplets here. Dictionary, how many bytes? Dictionary, which is composed by only this. This is the second index doing. It's traversing through symbol. How many bits? So this guy is using the stream of bits to get these 3. Oops. Okay. And this other index 2 is actually iterating through this triplet. How many triplets we have? The index 2 is handling that. How many bits? What's the interval of bits to get the symbol in one of the triplets? The index 1 is doing that. You see? So that's the idea.
One question though, go to draw. Regarding the bits, like when you convert it to a string, did you check it if it's converting right?
It's the same strategy that we are using. That I think I checked when I did the compression.
Okay.
We're gonna discover pretty soon if this is wrong, actually. Okay, and then what we are doing. So this index is the index for bits. So index for bits. And this other index is index for symbols. So we're gonna iterate through the index for symbols in the while, but to manipulate, it's Control D, yeah. For these guys, we're gonna just do 4 bits, and then we're gonna do 4. When we finish this, all these 4 things, this is when we finish a triplet. When we finally do all of those 4 lines, this means that we finish one triplet. We need to go to the next one, and so on and so forth.
Go back. Does that don't that index for symbols can be declared like inside? Do we need to keep track that like throughout different loops?
We don't. We need to keep track of it because this is not fixed. It's not moving by a fixed amount because of the size. We need to handle that like manually instead of doing in a 4 because this is like 2 bytes plus how many bits the bit representation is.
Wait a bit. Symbol.
And then you're gonna do symbol hash. Insert. So you're gonna convert this. Actually, the opposite is better. So it's bit representation to a symbol, which is a byte. And then this is now wrong because this is a string to a U8. Any questions? You can ask.
I'm trying to understand, but
okay. So let's go from the beginning. Okay, the beginning we just get how many symbols you're gonna have. So in this particular case, it's gonna be 3 because you only have 3 symbols in here: A, B, C. And then we have the string of bits, which is the entire file, which is this file right here, but in a string of 1s and 0s. And then what we are doing, we are getting the how many.
Wait a moment. We have the U8 buffer. We are iterating. Does that make sense? We are like converting to a string the whole thing and not only specific parts of it?
It makes sense because it's just making our lives easier, because there are parts of our thing, which is this guy, that is not a multiple of 8, which means that this can be 2 bits, 3 bits, but oh man, imagine that we have two tuples here. Imagine that we have this. We have 2 tuples, okay? Imagine that this
No,
guy
no, no,
is
wait. Okay,
one more.
I know why you want this as a string, but you are doing for everything, right?
No, it doesn't make sense to not make to everything. So just let me just continue here. So imagine that the bits, imagine that this is the scenario. So we have 2. Okay, so for a particular byte, or a particular symbol, we have the next 2 bits will be the bit representation, okay? Which is this, okay?
Okay.
But because the least amount, like the atomic unit that we're using is bytes, this guy will steal bits from this guy. So we're gonna have to make it, I don't know, 1, 2, 3, 4, 5, 6. So then part of this symbol byte representation is 6 bits in here and 2 bits in here. But this is gonna be the same problem, you see, because this will steal bits from this to complete 8. I don't know, whatever. And then this problem goes so on and so forth. So it doesn't make sense to translate only parts, because we cannot go anything more granular than 8. If we could, that would be great, but we can't. So what we are doing instead, we are translating everything to a bit string, so a string of 1s and 0s, and we are iterating by multiples of 8. And why? Because we know, for instance, we know that this is 8. We know that this is 8. We don't know if this is 8. But because we are manipulating with a more level of granularity, we can make these adjustments, like these finer adjustments.
Man, it's still a bit confused for me, but I think we should just let go and I could review that later.
Okay. No, but this is the like where the low level stuff actually comes to the thought process, because this is where you need to keep track. So it's hard. It's not.
I
It's not
don't think
normal.
that's actually the case, but okay.
No, it is. It is because of the we don't have to, we can't manipulate bits. That's what
No, no,
sucks.
no, 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 no. I mean regarding my comprehension of the thing.
No, but your comprehension is dependent on like the abstractions that we have. We cannot manipulate bits. You need to wrap your head around that.
How can I say? Well, let's just go.
Okay, so after this, will pick the entire dictionary. This loop. We have all the dictionary that we need here. Okay? And then the next byte that we're gonna have is actually the padding. So we can do something like padding. This will be what? Stream of bits, starting from index for bits, because this will finish the loop exactly at the point where the padding starts. And then you just add 8 here. And then you just do as U8. And then this is going to be a U8. So this is how many bits we need to drop at the end of the stream. Okay? And now we do what? We just drop the end. So, how to remove from last elements.
Maybe that's one of the part.
Assessing. No, I don't want to. I want to remove. Oh, the pop. Yeah, you're right. You're right. So we just do 4. 4. I don't know. Whatever in padding. Oh, I need to do in range in this particular case. I already forgot how to do range again. So for whatever in range is like this.
No. Oh, like number dot dot number.
Okay, so number dot dot padding. For this.
No. Like for e in, and then you can like forget the brackets.
And then we're just gonna do.
I'm not sure why the brackets are valid there, but
we're just gonna pop. We're just gonna pop, and then we are removing from the end the bits that we know are useless because it's just padding. Okay, and then now we can do the translation because we already have the dictionary. But before doing that, I want to print this dictionary. So let's try to do. So let's do a symbol hash. Okay, man. Commander is not here, so I don't know if our audio is actually good or not. We're gonna discover after the
Oh
report.
no.
Okay, so it didn't work. A bunch of errors. Not found in this scope. What do you mean? Don't you have a hash here somewhere?
Isn't a longer name like hash something?
Oh, it's hash map. No, but I'm using. Oh no, I'm not using. Okay. Wait, this is okay. That was weird. Okay. You're gonna have errors. That's okay. Okay, so non-primitive cast string as you wait.
That's the parse that we need.
And an expression can only be used to convert between primitive types.
It's a string and you want something else, right?
It's a string. Oh,
So
I
parse.
think I need to do as a string.
Oh.
Yes. That's my guess. Okay, let's see if that works. I changed this. Oh, it didn't. Remove this method call. No method name as str. What do you mean, partner? Am I doing this wrong?
What is the thing written?
The thing written
Can you
is
select the?
here. So it's saying no method name as a string for type string. So this is already a string.
Oh. Yeah.
Which doesn't make any sense.
Can you highlight the code there? Where you? Oh,
Yes,
okay. I
here.
see. I see.
So it's complaining about this. Maybe it's parentheses?
I don't think so, but I also don't.
You don't doubt it.
Yes.
No, it didn't work.
Try
Remove
to
this method.
use dot parse and remove the as you wait.
Remove what, sorry?
The as you wait.
See what happens. No. The parse returns a result, not that you
Oh,
wait.
okay, okay. Just unwrap or something.
I don't know, man. I think we already did this. Oh no, we did the opposite. Yeah, it worked. But I'm kind of curious how we did it.
The same way, I guess.
Oh no, it's like this.
Hmm? Wait,
Yeah, man.
what
It's like this.
stuff? What? No, wait. When was this code written, man?
It is when I said these lines here
Mm.
to write into the file. Those I made enough. Only those.
From str radix.
And this is translating a string that is a binary string in the it's binary because this is the parameter radix, and it's picking those this string of ones and zeros. It's translating from binary base to a U8.
Okay.
So it's exactly what we need. So instead of doing this,
Oh yeah, it's true. That would not work.
we just do this, and instead of doing bits, oh man, this is gonna be ugly as fuck. I guess it's like this. No. Wait. No, I think you can just remove this. It's gonna be something like that. Okay, so what are you complaining about? Expected whatever, got another whatever. Don't know what to think about that, but let's see if this works. I remember doing that previously when I was researching how to translate binary strings to. Yeah, it worked.
Nice.
Okay, so you just need to do that a bunch more times. So this is the same, but we just need to change this guy. So like this. And this is not what we don't need to change that. So let's see what happens. Okay. Okay, still a few errors. So line 121. Now it's complaining about the bit representation itself. Is this a string? Yeah, this is a string. I don't know why it's complaining. Expected use size, found U8. Oh, I need to convert this. How do I convert a U8 to a number?
Do we have some method? Or maybe it's the S? Yeah, I'm pretty sure it's the S.
Use size.
Not sure. Wait, isn't the opposite?
No.
Don't you want the U size as U8?
No, it's the opposite.
Oh, okay. Yeah, I just don't know if you need parentheses there, but probably don't.
It's complaining.
Oh, okay.
Oh, it's
The
because it's
string
expecting
type.
a string. Okay, we kind of don't care. So let's just use this. So let's just remove this. Oh no, we care. We actually care.
Yeah, actually.
Yeah, we actually care. So that's unfortunate. We actually care. Okay. Expected use size, same thing. So as use size. Okay, it's complaining about this again. String cannot be indexed by use size. String cannot be indexed by use size.
Oh, the way that you are accessing maybe it doesn't.
Oh no, you're right. You're right. This is wrong. It's index for bits plus 8.
Oh. Yeah, and there maybe you need parentheses there.
Now. Oh, it's the same. It's the same problem. So we need to do this.
Wait, don't you have a problem there in the indexes for bits plus 8?
Wait, man. It's just we just need to do a conversion. I was doing the conversion to U8 using the U as U8, but that's wrong. We need to do the trick. String of bits pop cannot borrow sim of bits as mutable.
Fair.
Okay, so this needs to be mutable. I don't know exactly
Pop.
who will break. Okay. Please work. I don't quite remember if this is right. Yeah, it is. It is right because this is A. And then A, it's gonna be only one bit, and I think. Okay, that's actually gonna be a nice sanity check. So let's print. Let's print the Huffman map. If they are the same, we are good.
Let's go.
So we're gonna do Huffman map Can we do a sanity check? Okay, this is not the print that we want. We want the bit representation. Yeah, this is the one that we want. Bit representation. Bit representation. Now the bot's too quiet. Classical.
Coded with plus
Yeah, it worked. That's nice.
0, 0.
How nice.
Yes, nice.
Okay, this is promising. This is not 100% trash. Now it's theoretically the easy part. Theoretically, this is the easy part because now we have the dictionary and we have a stream of bits. That's nice.
Let's map it.
Okay, so uh, while index for bits is smaller than stream of bits.len, while you didn't finish, just finish. So here, what we're gonna do? We're gonna have to do some sort of like there's another while here because now that there's the trick, right? Because let's go back a little bit because it's gonna be easy to
True.
explain. Because now we're gonna read only ones and zeros, right? We're gonna just read the text itself. We're gonna read the content itself. But there's a problem. We don't know. We can only read ones and zeros. So what you're gonna do? You're gonna read one. Like we're gonna read the first bit. We're gonna check. Do we have a symbol as our keys in our keys that corresponds to that symbol? So for instance, let's suppose that we read 0 as the first bit. Is there any key with the value 0? The answer is no. And then we're gonna do what? Read the next one. And then we're gonna do the same question. Is there any key with this 0, 1? And the answer is going to be yes. When we achieve a yes, we reset this guy. And then we're going to do again. So read the next one, 0. Do we have any zero keys? No. And then read the next, 0. Do we have? Yes. And then clear this. Next, read the next bit, 1. Do we have any key that is a 1? Yes. So translate and then clear. Any questions?
Nope.
Okay, so that's exactly what we want to do. So we need to first read the first bit. So that's going to be a bit. I'm going to call it, this needs to be mutable, and this is going to be bits actually. So this will start by stream of bits, starting in the index for bits position.
Oh, that's a nice one.
Wait a bit. Oh, we need to update the index for bits because it's locked into the padding. We didn't update it. We just read the next 8 bits. We need to update it because this is still like it's still pointing to the padding. We need to do +8 here. Now we skipped the padding, and now we can start decoding bit by bit. So you're gonna start like this, and you're gonna see while bit symbol hash entry of the bits. While this is something that I don't know, so hash map rust. I'm actually not listening to the song. Oh. Oh, okay. Yeah, this sounds good. Okay, so now we
It's
need to find a
starting, right?
function. We need to find a function that returns, like, do we have this key in the map?
Okay, get seems like a good.
Okay, so what get does? Returns a reference to the value corresponding to the key. The key may be borrowed from. Oh, so it's match a some or a none. How are we gonna
Hmm.
put that in the condition of the while? It's gonna be some. How are you gonna do this, man?
Wait a bit. What do you want is?
I want to check if I want to do a condition with the loop that the loop will continue until, oh, while this is none. Yes. While this is none, we're gonna do the following. Index for bits, we're gonna increment it to get the next bit, and then we're gonna do bits plus stream index for bits. So we are adding and the next guy in the line, okay? We are just adding a new bit in the line. And then we're gonna check again. Do we have that? Is still none? If it's still none, we need to add more, and so on and so forth. Okay? We're gonna break this loop when we finally get something. Do you agree?
You. Well, if that comparison works.
Oh, that's a good one. If that comparison works, which is a good question.
Uh,
Uh,
I'm not sure if that works, but I would find that dot is none or something, maybe a thing.
you sure?
Yeah, maybe, right? So.
Okay, so after that, we are 100% sure that we found the thing. So what we need to do? Oh, we need to actually declare the. So this is the output. Let mute output. This is going to be a vector of bytes. This is going to be vec new. So this is the output. We are close, man. We are close. Oh, commander is here. Okay, hello, commander. We are
Hello, hello.
doing the decoding process. We're gonna do output insert. What are you talking about? Inserts an element at position. No. I want a push. I want push. Yes. And then the
Do you
value
want
will
the thing
be,
on the end, right?
yeah, I want at the end. So it's gonna be symbol hash. Um, can we access the dictionary like this? I always forget. I'm assuming yes. But I always forget. Uh, what we want to do? I think we don't have a choice. What do you think about putting this into a variable, man? I think it's gonna be better.
Yeah, it's always better.
So let's put attempt of symbol, and this is gonna be this. It's gonna be this. And then we're gonna put attempt of symbol is equal to none. We don't know if that works, but we're gonna try. And then we're gonna be redefining it here. And then we're just gonna definitely the attempt will work because we're gonna break the loop. And then yeah, and then I just need to pick the bits and say that is equal to this, I guess, because we need to reset it, right? Because we found one. And that's pretty much it. Man, I'm excited.
Because you
Print.
are like Close.
Yeah, we are close. And if you're not understanding something, I can explain to you multiple times. That don't.
Not a
That's
problem.
not a problem. That's not a problem. If this works, it's gonna be rather interesting. So go, I guess. Okay, bunch of problems as usual. It's complaining about this comparison. String cannot be indexed by use size, which is rather interesting. Cannot be indexed by use size. What do you mean?
We cannot put a number to access a string.
Why?
Well, I guess that would be a SHA, right? But maybe you need to access in another way. Not as if it were like an array.
That's sad, to say the least. What if I do in like this?
I hope that doesn't work. Oh, I guess that we return a slice with only like hmm, one element.
Which is exactly what we want.
Is it? No, but if
Yeah,
we return this inside of a oh
yeah,
wait,
it worked. Wait, okay, it didn't work. Oh, that's sad.
doesn't have
Uh,
any sense.
oh, we need to convert this guy to to string. No, not this guy. Which guy? Hash map entry. Oh, it's this guy. To string. Commander, can you tell us if the audio is fine? Because I don't trust our things, our notion of volume. Yeah, didn't work. Oh man, that's sad. That's so
Okay,
sad.
a string of bits is a string, right?
Yes,
And what do you want is a
to
char?
pick a string that is only initially a char.
Uh, I
Ah, that's so
don't know.
sad.
Can you pop it? No, not pop in this case, right?
Can I pick a char and convert it to a string?
Sure.
Are you sure?
Of course. Is this
But it's saying again that string cannot be indexed by use size. I don't know what the heck this means.
uh,
Uh, Thanks. Oh, I need to be freaking kidding me, man. Can we do with how's it called? str?
maybe.
That would be nice. And then we just, I don't know, add some parentheses here and there and do some like this. Does this work? We need to index bytes via something. The commander is suggesting to convert it to bytes. String indices are ranges of use size. Man, what the hell? We cannot access a string by the position? Are you guys kidding me? Oh, this is what Commander was talking about, the graph themes. Why people do that? Look at this, man. Ah, man. Why? Okay, so apparently we need to do some sort of something really bad, like transforming the stream of bits as bytes, using the index for bits to get the thing, and then we can just do uh I don't know. Yeah, let's just put these guys. Oops. Let's just put these guys outside of this loop. They don't need to be there. Yeah, so I'm gonna do this, this, and this is also the start outside. Yeah. Okay. Okay, so here we are picking a byte, right? Which we want to be a char, right? And then we're gonna just do this as an empty string. Can we do empty strings like this, or we need to do string new? Maybe we need to do like string new or of some sort. And then we're just gonna do bits push C. Does this make sense to you?
Yes.
Okay, so there's also another problem. We need these inside the loop, which is sad. Okay, so Commander is saying that usually we use iterators for everything. Can we use iterators in this case? I don't think so, because this index is not like an iterator per se. It is an iterator, but
You
it's
can.
iterating through multiple things. It's iterating through multiple things, man, at the same time.
No. Wait. What you can do is, if you are iterating over something and you want to have the index of the thing instead of just the element itself, you can use dot iter dot something to get the element and the index of it. So you wouldn't need a while. You would just use the foreign.
Can you repeat that?
Uh, Show me what are you doing with index for bits.
We have a ginormous
No.
string of
Just
bits
select index for bits.
here,
No. Yeah,
and
this way.
yeah.
String of bits as bytes. No. Keep it selected. I'm looking at the code, the part that is highlighted.
Go here.
No, yeah, this way. String of bits again. Yeah, you are just using to access a string of bits, so you could as well just iter a string of bits.
No, but we need to do iter from string of bits, but not from the beginning. That's the problem.
Ah. Oh. Okay, I see.
We need to.
Yeah, but you
That's the
can
problem.
use. What is a string of bits? Is a string?
It's yeah, it's a string.
You could use the range operator on that string.
The range operator into that string.
Yeah, this way you select a part of a string. No, not range operator. Not sure if it's called operator.
No, yeah, but the beginning we just want one. That's why we need to do this thing, really pretty ugly thing. Because what we actually want to do, I'm gonna try to explain again. We want like to do in the beginning. We just want to pick the first bit, man. We don't want like in that would be a char. That is not a string. You see?
Okay.
Which means that I don't know. We need to do some sort of like a instantiate a new string and then push the character that we just convert to a byte to be able to index it and then convert back to a char again and so on and so forth. This is why it's a little bit of like it can be confusing. It can be confusing, which is it is what it is. But that's a problem. We want to we can't use iterators. Why? Because we're not starting from the beginning of the string.
Again, not sure if that that makes sense, man. You can start from anywhere you want with the
Okay,
string.
so we can start the iterators from anywhere. So how do we do that?
Like you have a string, and then you can access a part of a string using the range, right? Inside brackets.
Yes.
Then you iterate on that.
No, but we're not talking about the same thing, man. Okay, so Commander suggests us to see Advanced Iterator in Rust, which apparently is a thing.
Okay, like using
Next.
quote unquote by hand.
This can be a problem.
Wait, but you don't need to change the way you are doing, right? This is just for...
No, this is to continue using iterators, but instead of using... Because that would solve this problem of doing this crap here.
No, but that's not a matter of not working, right? That's just refactor.
Yeah, that's refactoring to be nicer. Just to be nicer.
Oh, we can finish first.
Okay, so bits found char. Okay, so you cannot concatenate using this. Let's try to do push then. Something like this. I don't know. Can we push characters into a string?
Yes.
Are you sure?
Yes.
I hope you are. Okay, so this equal none is not doing us any favor. Okay, so what entry returns? We need to discover that as well. So what actually
I guess.
returns? Oh, we are doing it wrong. I think I did entry. No, it's not entry, it's get. Okay, so get. And it's expecting what? Expecting an address. And then we need to do is none, which is fine. And I also noticed that this needs to be a new. And no, almost there. Mismatch types expected due to this value. Expected enum option found hash map entry. Hash. I'm doing dot entry somewhere. Oh, here. This is get. And this is a reference. Okay. Iter advanced by 8. Oh, so you can advance the iterators multiple times in one line. That's nice. Okay, and if we have time to refactor, you can refactor that. So expected reference found option. Oh, it's because this. No, but this is fine because we can just unwrap. And this is expecting a reference. So let's do this. The trait borrow is not implemented for string. Oh, it's because I need to... We can clone it or we can borrow. What do you want, Nathan?
Wait, what is the one that you are doing?
Here.
No.
Because
wait. What is the str that you are trying to use the address? Just forget the address.
we are trying to pick...
No, show me the error on the compiler.
Oh, here.
Is it the attempted one? Or...
No, I think it's the symbol hash. I'm trying to access the value of the symbol hash and push it to a new guy, so it's complaining about borrowing. We could also do the two owned, I think.
Output is evacuate. We are trying to push symbol hash. Symbol hash is what to what?
It's a dictionary from a string to a string. Or to a UH to a string, I don't remember anymore.
Oh wait, but you are pushing on evacuate, man.
No, I'm the value of for a given key is a U8. That I can.
Oh.
I'm sure. But the problem is that it's complaining about bordering stuff. The
What is
following
attempt of
implementation.
symbol? What is the type of attempt of
It's
symbol?
an option string.
Option. Oh.
Yeah, it's an option. Should be an option string at least. Oh no, wait! It's an option U8 according to this. Wait. No, but this is fine. This is a U8 to a string, right? Let's see. Symbol hash. Yeah, it's a. Oh, wait. We are doing string to U8, man. So how the heck this is an option U8?
Symbol hash dot get.
Oh, this is the result. This is trying to find, given this string, this is trying to find this result. Makes sense. We're just dumb. Okay, so we are picking a string and trying to find the value of the corresponding string, and that is a U8. That's correct. But then, oh, we don't need any of this because this is the attempt symbol is already what we want. Just do unwrap. Because the output is a vector of U8s. The attempt of symbol is an attempt to find a U8. If we pass through this loop, we definitely found the U8, you see? So we just need to do attempt of symbol unwrap. Because this output is a vector of U8s. No. Wait,
Consider
expected
the
U8, found the reference of U8. We need to dereference?
That's unusual.
It is even suggesting that. Okay, so
Oh wait,
what?
what is beats?
Bit is never read.
What?
What do you mean, partner? Of course it is. Bit is being read here.
What?
Yeah, it's going a little crazy. Cannot assign twice to immutable variable byte. Okay, so this needs to be mutable, and this guy also needs to be mutable. Same thing for the byte itself. Okay, so there's a warning here, and it's locked in a loop, and not ending loop, which means that something along these lines didn't work. Do you agree?
I hope so.
Oh, I know why. Because the index for bits. Wait.
Are you incrementing that? Oh.
We are incrementing, but only here. We need to increment it here as well. +1. Every time you consume a new char, we need to increment the index for bits. Okay, so it's panicking. So index out of bounds. The len is 87, but the index is 88.
Off pile.
Sure. So let's try to do -1 here. Sure, why not? Ah! Oh man, it almost worked! It almost worked!
What is the
It almost worked! This
99?
is so sad! Because I think we have how many A's? We have 5 A's here. And in the test we have 5, which is fine. And then we have how many B's? We have 4 B's, which is not... Yeah, we have 2 extra B's. And we are missing 1 C. I guess? Okay, let's try printing everything. I think it's a good move. So let's start by printing. Now Let's start by printing the bits. We want to see the bits, okay? And we also want it here. Okay, so this is gonna be our first guess. Almost there, almost there. Okay. Okay, so it found all of these ones. So A.
Zero and zeros.
Holy jeez,
Zero.
but this is wrong. Isn't this wrong? How many ones we have?
Ah.
Holy Jesus. 1, 2, 3, 4, 5, 6, 7, 8, 9,
Wait,
10.
go back on where you are printing this.
Here. Oh, it's because I'm printing 2 times. Yeah, this is wrong. This is definitely wrong. You're right. That's more like it. Okay, so we have 5 ones, which is correct. Which is correct. Then we... okay, so we are doing this in a dumb way. This print is wrong. It's after the while. Today is a rough day.
Like rough. Eh?
Okay. Okay. So 5 ones, which is 5 A's. And then we have a B. We should have 4, but apparently you have more, which seems to indicate that or the bit string is wrong, or we are reading it wrong, which is sad, to say the least. Which is rather sad. It's really sad. Okay, so we don't have a choice, man. We need to debug the stream first. So print ln. So let's debug this guy. Stream of bits. Okay, are you ready? So let's go. So this is how many symbols we're gonna have. The first 8. Okay? So this is 3, which means we have 3 symbols to go. Okay? And then this, I think, is the number 90 something. It should be the number 90 something. 332. What is this number? Let's Google it. Okay, binary to decimal. Binary to decimal converter. This is the 98. So this is this is the B.
Look at the ads.
Okay, so this is the B. Okay? 3 3 2. Okay, so this 3 here. So this is the B apparently. Yeah, this is the B. How many bits we should use for the B? 2. So we need to find a number 2 now. 3 3 2. This is 2 in binary, okay? That's fine. Is that fine?
Yeah.
Okay, so and then we need to find how many. Okay, these 2 zeros then, okay?
Wait, what are those again? Those 2 last ones?
Here, can you see my mouse?
Yeah.
Okay, so maybe making
No, but what are those again? What are they representing?
We have how many symbols? And then we have the 98.
Sure.
And then we have how many bits this byte is being represented. Okay? And how many? This number is 2, right?
Yeah.
So the next 2 bits represent the 98. So these. Questions? The relationship is always the same, which is we have a byte, and we have how many bits this byte is being was converted, and then the 98 has 2 bits. And so
Oh,
the next
okay.
2 bits is the 98.
Okay, now I got it.
3, 3, 2. And this I think is gonna be the something like 99. Yeah. So I'm already lost again. 3. Okay, so let's do something smarter. Let's copy this. Because we are dumb, but not so dumb. Okay, so this is how many symbols. This is the 98. This is how many bits. This is the bits themselves. This is the 99. This is how many bits. These are those. Then now we have how many. This supposedly is the 97. Then this how many bits? The bit.
Nice.
And then we have the
Padding.
what the hell? Oh, we have the padding, which is in this case is 0. Then we have
Ah.
A, B, B, B,
Wait. Is
B.
the padding after the?
Yes, it is. We're
Okay.
gonna go back there and then C, C, C. Okay, so this is right. This means that the encoding is correct. Okay,
Okay.
which means that we just need to see if we are doing things in the correct order. So first things first, we are getting from the buffer 0 how many symbols. So we are getting this number here. This is the how many symbols. How many symbols? Okay. Then we are doing an iteration through the stream to get this mapping, because this is what I'm calling a mapping. Okay, so mapping, which is to form this to consume these triplets. You see?
Mm.
So we are doing those. How many times are necessary? And then after the loop, what we are doing, we are getting the padding, which should be 0.
Let's see.
It's 0.
Nice.
Okay. And then we are removing the padding from the end of the stream because we know that they are useless, right? In this particular case, because it's 0, we don't have to eliminate any.
Oh wait. These. Oh no, the range supposed to. Okay. I thought we had off by 1 there, but.
Yeah. So now we put the index for bits uh, after the padding, because here when we are getting the padding, we are not updating the index, because this indexment is what we are using to move throughout the stream of bits. You see? So okay, and then what we do? We start iterating through this part. These guys. This is the last part. This is the last loop. You see? But then something along here, something along here is happening that we are not doing at some point we stop translating it correctly, because as you can see here, we have more than 4 Bs, which means that something along the indexing is wrong. And that's not nice.
What about you printing the string of bits starting from where we want to see if it's what we expect? To be sure that the error is inside the while.
Just one sec. Let me just try to remove this, just to see an hypothesis. Woo!
Oh,
Okay. Okay, so this was definitely necessary. Okay, so what do you want to do?
You are going through the string of bits, right? So
Yeah, we are picking char by char, you can say.
yeah, but you are not starting from the beginning. So
We are not starting from the beginning.
can you print that only the part that you are going through the while? Because if that's correct, then the error is inside the while. So you do
Wait
like
a second.
a string of bits, and inside of that you put a range from index for bits until wait. Well, for 8, right? That is your first index for bits, I guess. Oh no, wait. Just a second. Go up a bit. Yeah, index for bits. What is this +8 that you have there?
It's because when we get the padding, we need to move the imagine like a needle.
Mm.
Okay, we
Oh,
like a
yeah,
pointer.
I know. Like index and you're just adding, but
Yeah, and then we are adding because we need to jump the padding.
yeah. So what you can do is after you incrementing this index for bit +8, you can
Mhm.
print the string of bits from this to the end.
Nah, that's a good call. So stream, it's like this, right? Like this.
Yeah, I guess so.
Okay. I don't think it's like that.
You
uh,
have a known size at compile time.
uh, see if this works. Nope. Which is rather interesting to say the least.
Um,
Doesn't have a size at
what
no.
is the string of bits again? The type?
It's a string.
Which string? The with
It's yeah, it's a
uppercase
string.
S?
Yeah, uppercase S.
Oh, try to convert before.
Convert to what?
Wait, but that doesn't make sense. Yeah, but try to
So
convert to a str.
as str and then do the indexing.
Yeah, let's try it. Or no, actually you can. Yeah, you need that.
Then do what?
This. Let's try it.
Nope.
Oh,
Doesn't have a size known at compile time, which
I
is
don't know.
pretty weird. Pretty weird. Doesn't have a size known at compile time. So you cannot
Just
print a substring. I don't know how I feel about that. That doesn't make any sense to me. Okay, so let's try print a substring. Yeah, so people are talking about doing exactly what we are doing. And then you do a conversion as a string. Maybe it's parentheses. Uh, yeah, people are not really happy. It doesn't have, man. Doesn't have. Why though? I don't understand it. You know why, Nathan? Do you know why?
No. Uh,
Why the heck this is not?
guess it's still. Can you even print it at all? Like
That's a good
everything?
question. That's a good question. Let's try to print just the index for bits. Index
No, wait, but
for bits.
in what will that help us?
I just want to see if we can print things. Yeah. No. Oh.
69.
Okay, so Commander sent a piece of code. Let's use it because who cares about trying to do by ourselves? So let's try. So stream of bits char skip index for bits take m. I don't want to take though. I want it all. So can I do this? And then we just print the slice.
Nice.
Thank you, Commander, our savior. Consider giving slice a type. Why?
The
Why
way the
should I be?
collect works, I guess.
Okay, but this is a string.
I think it's like parse. You need to give it a type.
Oh! It worked! Okay, so how many is bees? 1, 2, 3, 4, C, C, and then there's a lost 0.
I lost it.
Yeah, so... Oh, we are eating one. We are eating one, man. So
We
maybe
are-
this is 7. No. Okay. Okay, so how the heck we're really eating one? I don't understand it. Oh, this pop? Is this pop? Oh, man. Let's see. This would be bad. Please don't print. Just don't. Oh my god. Man,
So this is
why? So we are popping unnecessarily. Oh man. We need to do an if, man. How terrible. You understood why?
Well, because we have 0, right? So it will always have at least 1.
No, but the padding is 0.
No. Yeah, but you will have a range with at least 1. So even though the other is also 0.
That's terrible, man. Yeah, but this is still wrong. I'm doing something really wrong now. Maybe this is also now a number 8? No. Yeah, we're doing something really wrong now. Because now it's starting with 0. How is that possible? I'm not understanding how is that possible. And did I save this before running? No, I didn't. Okay. So this is also wrong. How? Man, you see this one?
Yes.
We are losing it.
Where are you printing? These that have the 1?
In the beginning of the thing. So let's see if this if is doing its
Oh,
job.
you are
because I
checking
don't-
if it's equals 0.
Yeah, and it should be what?
Wait. Isn't it supposed to be different from 0?
Oh no, you're right. I'm dumb. I'm the dumb one here. And okay, now we have a problem. But now this is correct. Can we agree that this is correct?
I hope so, but where
So we
is
have 5
this?
ones, and then 1 B, 2 Bs, 3 Bs, 4 Bs, 1 C, 1 C, and 1 C.
And what about this index out of bound?
Okay, so we are doing some sort of indexing out of bounds apparently. But until this point, Like until here, we are kinda safe. Okay, so now we need to think about who is doing wrong things.
Well, actually, you can just see the line.
See, oh, the line. Which line? Oh,
Source.
161. 161. Here.
No, actually,
Oh,
beneath.
here.
No. After that, like
Oh, so
162.
this one.
Yeah.
Hmm. Interesting.
Is that because you are increasing before that?
Probably yes, but that should not be the case, man. You know why?
Mm.
Because if we enter this loop, this means that we don't have a symbol that we can find in our dictionary, which does means that we need to increment one and pick the next one,
Ah,
if I'm not mistaken, of course.
attempt of symbol. But attempt of symbol is only by as a chart. But
Okay, I want to do something, man. So let's pick these bits and let's put it also before trying to find it. So yeah, so this should return to us like 0. Like it should be 0 and the next one should be something else. Yeah, here. Okay, so the ones worked. Okay, you see?
mm,
And then, oh, oops! I found a 0. And then this means that it couldn't find it because it added the next 0 to this previous one, and
mhm.
then it find it, and then it found it, and then it restarts 0, 0, 0, which is also correct. We need to have 4 pairs of zeros, which is exactly what we have, right?
Mhm.
And then when we reached at some point 1, 2, 3, 4. What the heck? 1, 2, 3, 4, and then we. Huh? Something is really wrong. Because this is a B, and then this is a B, and then this is a B, and then this should be the last B. So this is wrong. So we are not updating something. Huh? Does that make any sense? Does that make any sense? I'm not sure. Oh! Wait. Maybe this index is after. Yeah. Maybe this thing is after. Wait. Yeah, it worked! Okay, so what we were doing wrong. After we attempt and we finally get out of this loop, we already consumed a new one. You see?
Yep.
So we need to increment again. And sometimes this loop is not necessary. So when we do, for instance, when you find the bit 1, for instance, you're gonna have the 1 here. And then this attempt will succeed. Okay? If this attempt will succeed, we're not gonna have this loop. And if you're not gonna have this loop, you need to increment it to go to the
Okay.
next one. Yeah. Okay, so this worked. Which means that we can write to the file.
Oh yeah.
And I think it's this. So let's just do a sanity check. And let's add. Oh my god, this file is huge. Original. I
Do you
don't know.
call this huge?
No, this function is huge. Sorry. And then we're gonna just copy paste. We already copy pasted. We need just the result type. What is the result of this crap? This. And this. Like this. And then in the main, we're gonna do let decode result is this. And then let's do a match. And then the type is going to be the exact same as this. And then it's going to be decode. And then decoded. Here we're doing decoding. And why are we are having, oh, it's because the type signature I changed it, right? Yeah. So let's just go here, decompressed. This will be the original file name, and then the decompressed, you're gonna write what? The output,
Original file name.
and then you're gonna return an OK, which means that this guy needs to receive also the file name. And I think it's a reference, so it's like something like, I think it's also mutable. No, it's
The
not mutable.
file name?
No, it's not mutable. It's just this. It should be just this. And let's. Okay, there's a problem. There's a fundamental problem with this. How can we push into a string like an str instead of like a string with a capital string?
str.
Push str. Okay, so let's do that. Push str. Let's do a dot test, because otherwise it's going to override our original one.
I'm not sure what's the return of push str. I don't know if it's the string itself, but it apparently is, right? Because
no, I don't know. It's not complaining.
yeah, that's why.
Okay, so let's remove all of these. All of these. You can remove the padding. I'm okay printing this symbol hash. Oh, and I can also remove these. Okay, so let's try. Let's see the chaos.
Oh no.
And method not found in address string. Okay, so we need to oh man, this is gonna be a lot of parentheses.
Wait. What is the original file name? What is that?
That is test.txt.
No, but where is that?
It's a parameter that we are receiving.
Oh. Okay.
But this is just for testing purposes.
Yeah, so just put it hard coded.
Okay. Let's do that then. Instead of doing something like this, we're just gonna do. Okay, so this is we should definitely remove the prints. And these two, which are both in here. Okay, symbol hash is done. And I think we are also printing the. Do we have any print? Yeah. Let's also eliminate this. Because now, my friend, the prints will start to get crazy. When you actually put real data into this thing, you cannot debug it. And it's broken. Hey! How nice! We still have a little warnings. I don't know if this is intentional. Oh, we can remove the slice because the slice was just to print. So it's complaining about this being not used. And bits is never read. Yeah, but this is just wrong. This is just 100% wrong.
Can you go on the declaration of bits?
Yeah, here. Do we have any method for like clear? Clear?
Yeah, we do have.
Okay. And original file name. Yeah, this is being used because we are hard coding in this thing. Yeah, this is the same. And it didn't work.
Well, but yeah, of course, that was not a warning, right?
Can we didn't save this. I don't know if that's important.
Wait, but have you saw the error?
No, the error is because it
Accessing
panicked because they not found the key in code 110. Let's just try to do after saving the main. I don't think it will work. Yeah, it doesn't work. Okay, so let's do a little bit less fancy things.
No, but you still have the referência there. The accent. Try to raise the accent, man.
Oh, you think it's this? Nope.
Oh wait, is it the slash n? That would be funny.
Slash this slash?
Slash n.
Yeah, this.
Yeah.
Hope not. Yeah, no, totally not.
What the?
Really not. So something broke. And it broke it in here, by
Uh...
the way. How did we manage this? Like, we managed to have a one, like, how many? Oh, this, it's even saved. This is working. But Dom Casmurro is not working.
Wait.
Is it
No,
a
no, no, no,
space?
no, no. Go back. Oh, that's a good one. We can. No, no. Yeah, we can test the space or uppercase letter. We can go crazy on this.
Uh.
Okay, now try space.
Ooh!
Oh.
Okay, so this is definitely very bad. Because it's picking 3 characters and does not know what to do with them. Okay, that we already we are on time, 9 p.m. So we need to do this next time, which is really sad because I thought this would be, but I was being naive because Huffman is always like this. You
Uh,
started okay and then you just go
mm,
whatever.
yeah, that's a bold claim, but
No, it's not a bold claim. This happened to me when I did the first time.
no, no,
Like
yeah,
I did
but that
an
doesn't mean
example.
like we are doing a wrong implementation. Doesn't mean that oh, Huffman is like this. Always when you try to
No,
encode it,
all
you get it
compression
wrong.
algorithms you forget corner cases, man. This is
No, no,
always the case.
but that's software and that's not. Oh
Man,
man, but
I think it's the padding. I think the padding is
dude.
wrong. I think the padding is wrong.
Oh.
Because if we have only one character, this should have 7 of padding, right? No, I don't know how many actually. Oh, and now we get an error. How interesting.
Some somewhere else.
Um.
Oh
Okay,
wow.
I want to read this guy as a. Like, I want to read the hexadecimals of this crap.
Man, just command line.
Uh.
I think you
Oh,
have.
I don't want any of these. Oh, we have more. Okay, I want just the bytes. Can we have the
Man,
bytes?
go to the command line. Like I think you will not find these there.
Cat.
No, no.
Test.
Don't you want like hex dump or something?
X dump like this.
I'm not sure, but try that. I think you need to pass some flag.
Like what? For what?
I don't remember.
Man, is this the first byte?
This is the address, I guess.
Oh, this is the address.
Well, I guess, not
Oh,
sure.
this is in hexa. Yeah, that's
Yeah.
right. This is in hexa. So this is the content.
Man, just put like man hex dump. We need a flag there. Mm, format string, format file. Oh, octal, 1 byte, canonical. Mm.
We want binary representation. Can we have
Oh,
binary representation?
so 1 byte. I don't know. Try this BOC. It's one of. Oh wait. Oh, X.
Okay, so let's just use the best way to do it. So hex dump in binary. Nice. Oh, we need an application for that? Oh, here. So apparently dash C. Dash capital C.
What?
I don't know, partner. Are you sure?
Wait, did you read the question? How
Yeah, the
binary?
question is how to view files in binary from Dash,
Hmm.
which is exactly what we want to do.
Ah. Huh.
Do we have XXD? Is this a thing? If it's not a thing, I'm gonna
No,
be
no,
really
it's because
surprised.
I think some of those, when you don't pass the argument, they just do shit.
Oh,
So,
so XXD minus B test D. Oh, here it is.
it's-
Okay, this is correct because this is how many symbols we have, and you only have the letter D. Uh, then this is the symbol itself. So this should be the 90. This should be 100, which is not. Oh no, it should be 100. This is capital. This is capital D.
it's just
So
subtract
we,
the
we
number
lost
of
our we lost our reference. So 68 in hexa.
in Exa?
Yeah, it's 68 in hexa, right? 68. Oh no, it's in decimal. Sorry. So decimal 68. It is the D. Okay, that's promising. Then one bit for it, and then
One.
this, whatever is this.
Wait, but you have
Oh,
your
1 bit
one,
is
right?
this. Sorry. Yeah, so it's this one. What comes after that?
Uh oh.
Oh, the content. Now comes the content. Uh, okay, so this is wrong.
Why? Oh, because should be the
This should be 1. No, no, no. This should be how many. This should be now we need to know how many of padding. Yeah, now how many of padding? I was wrong. So 3, 3, 2. So is this 7? I don't think so. Oops. Oh, this is 6. Okay, so it's saying that we have 6 bits of padding, right? Do you agree?
yeah, and it wait.
It's right.
Ah, no, because you have one there.
No, 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 but this is the D. This is the D itself. Let's go again. Let's go again.
Oh.
How many symbols? Then the symbol, how many bits, the bit, padding, the content. And then this is all padding.
Oh, okay, yeah. The content they encoded, right? Oh, okay.
Okay, so the
Yeah,
encoding
it
is
is
right. It needs to be right. Which means that our problem is again in decoding. Which sucks because it should be the easiest one.
Hey man, but we do have to go. At least we have a
4
notion
minutes, man.
on where
4
the problem
minutes.
is.
4 minutes. Oh, I'm really sad that I removed the slice. Can I get back the slice? No, I'm gonna lose things that are. We are so close! Because the encoding is right, man. We definitely can see. We are doing an extra pop because we should have 6 zeros and
No,
we have only
yeah,
5.
so what I mean pop again is the problem there again?
Oh, this! Yeah, maybe actually needs to be -1. Although that doesn't make any sense to me. No.
What is this index out of bounds?
It's because we don't have the extra zero here, we are in the code here is kind of
Oh.
assuming.
Mm, yeah.
Which means that Which means that the padding needs to be wrong. The padding needs to be wrong.
Oh. Mm.
Padding. If this
Maybe
print
this
6.
index for beats there. The way
What do
you
you
are in.
mean? No,
Uh,
it's 6. What
okay.
the crap? What the actual crap? 4?
What about you do a skip, man? You do a skip on padding. Oh no, not. Oh no, no, no. I'm talking shit.
Crap. What the heck, man? Is this loop? No, man. I'm really worried about this. So let's do just
Yeah, for n
this
and
is
print
dumb.
n.
What the crap? Huh?
One time, right?
But this is wrong. This should be doing 6 times.
Man, I know why. I think it's brackets.
Brackets? What do
Remove.
you mean? Oh no! It's this?
Maybe.
Oh man, I'm gonna be so sad.
Not sure if you would need the -1 or.
Now it did 6 times. Now it did 6 times.
But
But it's
do you
still
need that?
so close. And I still don't understand why.
Man, but we will get it on the next time.
But that's the thing. We still have to test special characters, and that's gonna.
No, 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 but that's next session, man. But hey, I do have to go, man. So let's wrap
Okay,
it up.
so you can finish. You can finish.
Okay, so are you going to stream, right?
Yeah, in the stream. Bye,
So,
Commander.
bye, Commander. Thanks for
I don't know where to
coming here.
decompose though.
So, see ya.